This session we will discuss probability distribution, mainly binomial distribution and normal or Gaussian distribution. In today's world, data is becoming increasingly important. Entire professions are dedicated to studying, understanding, manipulating and processing data. It is important to hence know about different types of data and their associated properties. A probability distribution is a mathematical function that defines the likelihood of different outcomes or values of a variable. The function is commonly represented by a graph or probability table, and it provides the probabilities of various possible results of an experiment or random phenomena based on the sample space and the probabilities of events. Probability distribution are fundamental in probability theory and statistics, or analyzing data and making predictions. Types of probability distributions: Bernoulli's distribution, uniform distribution, binomial distribution, normal distribution, exponential distribution, Poisson distribution. Mainly we will discuss binomial distribution and normal or Gaussian distribution. Before this, we have to know random variable. What is random variable? The variable involved in probability distribution is called a random variable. It is random variable because it can take different values as a result of a random experiment. We don't know what will be the output of a dice, but we know it will be the number between 1 to 6. A random variable can be continuous and discrete. The probability density function is defined over a specific range. By differentiating CDF, we get PDF, and by integrating the probability density function, we can get the cumulative density function. This is very important topic. Binomial distribution. A distribution where only two outcomes are possible, such as success or failure, gain or loss, win or loss, and where the probability of success and failure is the same for all the trial is called a binomial distribution. If the probability of success in a experiment is 0.2, then the probability of failure can be easily computed as q equal to 1 minus 0.2, that is 0.8. Like coin toss, each trial is independent since the outcomes of the previous toss does not determine or affect the outcomes of the current toss. An experiment with only two possible outcomes repeated n number of times is called binomial. The parameter of a binomial distribution are n and p, where n is the total number of trials and p is the probability of success in each trial. Based on the above explanation, the properties of a binomial distribution are: each trial is independent, there are only two possible outcomes in a trial, success or failure. A total number of n identical trials are conducted. The probability of success and failure is the same for all trials. Trials are identical. The mathematical representation of binomial distribution is given by like px in combination x p to the power x q to the power n minus x. Mean here n c x, that is factorial of n by n minus x factorial p to the power x and q to the power n minus x, where n the number of trials or the number of being sampled, x the number of successes desired, p probability of getting a success in one trial, q 1 minus p the probability of getting a failure in one trial. You can see this, the binomial distribution formula is here. Coin flip probability calculation. If we flip a coin 4 times, what is the probability of getting one head? One head. We know binomial distribution formula, px equal to n combination x p to the power x 1 minus p to the power n minus x. Here x equal to 1 mean desired success is 1, mean getting one hit. So number of trials is 4 factorial 4. So factorial 1 4 minus 1 factorial 0.5. Actually 0.5, because probability of getting a success on one trial, a coin only head and tail. So p equal to 0.5 to the power 1 minus 0.5 n minus x, mean 4 minus 1. Now we can get four 0.5 multiplication 0.5 to the power 3. Zero 0.5 to the power 4, that is equal to 0.25. So we get 0.25. The probability of getting one head is 0.25. What is the probability of getting two head? If we flip a coin 4 times, that time P x value equal to 2, P2 equal to factorial 4 mean factorial n by factorial x mean factorial 2, n minus x 4 minus 2 factorial, then p to the power x mean p equal to 0.5 to the power 2, 1 minus p 0.5 to the power n minus x 4 minus 2. So we can get, that is 0.375. So what is the probability of getting two head? That is 0.375. Now the probability of getting three head, when we flip a coin 4 times, P3 equal to factorial 4 factorial 3 n minus x mean 4 minus 3, p that is 0.5 to the power x mean 3, 1 minus 0.5 to the power n minus x, that is 1. So just like probability of getting one head, and value will be 0.25. Same way, the getting 4 head when flip a coin 4 times, P4 equal to factorial n factorial x 4 minus 4 mean n minus x factorial p to the power x 1 minus p to the power n minus x and 4 minus 4. So we can get, that is 0.0625. That is for getting 4 head. If probability of getting 0 head mean no head, only tail. When flipping a coin 4 times, that will be same result. We can see the coin flip probability distribution plot when number of flips equal to 4, mean n equal to 4, a fair coin, so p equal to 0.5, getting no head, only tail. Probability is 0.0625. Getting one head, that is 0.25. Getting two head, 0.375. Again three head, 0.25, and four head, 0.0625 probability. So we can see this is our distribution plot for flipping a coin 4 times. Next, we will discuss normal distribution or Gaussian distribution.